The idea of a home that incorporates computing power, also known as a smart home, is not a new idea. Throughout much of the 20th century, people have been fascinated by the concept, and many have expected that smart homes would be the natural future of mobile computing technology. However, there are a number of enabling technologies that had to arrive in the market before this was possible. Firstly, computers and sensors had to be small enough to fit into reasonably sized devices, which was essential for making integration of computers into the home a possibility without ruining the natural flow of a house. Furthermore, the introduction of wireless connection protocols such as Wi-Fi and Bluetooth now form the backbone of the Internet of Things, and these were essential in allowing connections between devices and each other, as well as devices and users. In more complex tasks, very recent developments in machine learning and artificial intelligence have also been a key enabler, with more sophisticated comprehension of human-like tasks being required for making our lives easier. So in the modern day, we have all of the technological components required for smart homes to be a reality, and it is now more of a question of how companies design for these technologies and how consumers respond to and adapt with emerging smart home ideas.
These presentations will cover about the topics related to the three main approach of the smart home connection. First approach is the mobile-enabled connected homes. For example, like the Apple HomeKit and the Amazon Alexa, which allow the users connect to the smart home device through the Wi-Fi and the Bluetooth. And another approach is the freestanding hardware device. For example, like smart speaker and smart TVs, which can respond to the user commands without need to connect it to the ecosystem. And the last approach is the proactive home controls, for example like Tesla Power, which can automatically help users to manage and control about their house energy consumings according to the weathers. In these presentations, we are talking about the critical analysis of the three main approach along with their pros and some limitations. And we will present about the summary of the analysis. At the end of the presentation, we are also talking about the future directions of the smart home according to the analysis. Now, let's move on to the main points. First is the control smartphone base, which is the mobile-enabled connected homes. Nowadays, most of the smart home ecosystem can be controlled by their mobile applications, like the HomeKit system can be controlled by HomeKit applications. Amazon Echo can be controlled by the Alexa applications. Noticeably, the connection approach used for connecting apps and systems are also quite diverse. In the smartphone-based control with the ecosystem, the most popular way to connect to the smart home device is the Bluetooth and the Wi-Fi. Bluetooth can establish a stable connections between the device and the ecosystem, but it limited on the connection range. On the other hand, Wi-Fi, which is well-ranged, but the ecosystem need to connect it to the similar network as the smart home device. Moreover, most of the ecosystem are able to work with the smart home hub, so as long as the hub connected to the Wi-Fi similar as the device, each allow the user to control the device even they are in the different network. Now, I pass it to the Glenn to talk about Zigbee and method.
Zigbee is alternative wireless method for connecting smart devices with its mesh network architecture, allows devices within its network to communicate seamlessly. When compared to Wi-Fi and Bluetooth, Zigbee has a way impressive on energy efficiency. However, its limitation is still in bandwidth speed. Also, a new connection approach called Matters launched in 2022. It allows to connect it with different ecosystems, and it combines with different approaches like Wi-Fi thread for different smart devices. However, to combine different systems, the security is still a challenge for them. Since Matter is still quite new, the supporting market is still limited for them when compared to a mature approach like Zigbee.
A category for smart home device-based depends on the device themselves, acting as channels for user interaction, primarily driven by the voice and gradually embarrassing gesture recognition. Voice interaction like Siri empowers users to command smart homes through spoken directives, yet it harmonizes with integrated control platforms like HomeKit. This synergy across various smart devices onto one platform, streamlined and controlled by Siri's vocal cues. Siri's voice recognition converts speech to text, deciphered through intention recognition tag. This interpreted data flows through HomeKit, orchestrating device actions. Gesture recognition is another part which deciphers meaningful human movements, offering efficient human-machine interfaces. This technology uses high-definition cameras to detect and interpret user gestures, translating them into commands that control various devices. Samsung Smart TV showcased this concept, capture hand gestures through cameras for remote control. Xiaomi's Pepper Lamp takes it further, integrating AI-driven gesture interaction to adjust lighting and angles.
Device-based interaction has transformed how we engage with technology. Just imagine, without touching the device, users can simply use voice or gesture to control their device. It's not just convenience, but also reduce the memory load. However, there are some challenges with voice or gesture controls interactions. When you voice a command, it often feels like making a suggestion rather than giving a direct orders. It seems like with the voice system, while the problem in the accuracy of voice recognition. Moreover, another problem is the lack of visibility and recall. Once a voice commander is given, it will dissipate, leaving user without a visual cue to remind them of their action. Now let us talk about the gesture recognitions. Like when you move your hands to control something, it sounds cool, right? But it's not always perfect. Sometimes in low light or if something blocks the view, it doesn't work too well. In conclusion, while device-based interactions promise in a revolutionary future, it's imperative we address their challenges to truly harness their potential.
The third type of smart home approach that we'll be discussing is proactive smart homes. These are smart homes that are context aware and make decisions without notifying users, essentially working in the background. Whether this be something like managing lighting, managing temperature, or even something complicated like managing a calendar, these systems are designed to make predictions about what users want and to do it in the background without notifying them. One case study that we'll look at here is energy management, which has been a very popular case study for this type of smart home. Because this is a very complicated topic and users are not able to do this themselves, smart homes are able to benefit from the variations in prices for electricity on the grid. So because electricity can vary as much as 15 cents to 55 cents in Australia, smart homes are able to schedule activities for times when they can buy electricity off the grid for very cheap. So energy-intensive activities such as laundry or charging electric vehicles can be done at cheap times of day. This is also beneficial to the environment since the environmental cost of electricity is different at different times of days. So smart homes are not only able to save users money, but can also improve the environmental outcomes and lower emissions. One key player in this market is Tesla, who also tie their product into what they call the power wall, which ties into their battery products as well as their solar panel products. What Tesla does is also sell electricity back to the grid that users are generating on their roofs. And this is also part of the scheduling process. So they're able to sell electricity at higher prices and predict lower prices for when to buy electricity in cases when users run out in their batteries. However, whilst this specific example of energy management has been very popular in the proactive smart home space, many other products have not been as popular and there's a lot of user pushback. And this is largely because most of these proactive smart homes require a large number of sensors, especially video and audio sensors in the home that constantly look at and listen to all of the people in the house and try to make predictions about what they'll do. And many people find this quite intrusive, as well as potentially worry them about security implications. Essentially, for these smart homes to be proactive, they need to not only be able to tell what a user wants by a user explicitly telling them, but also be able to predict what users want. And for this, a large amount of data is required. So this problem is still quite ongoing. However, despite this, many people believe that this is the future of smart homes, and many researchers discuss the smart home market in terms of phases, with devices being the first phase, connection and the Internet of Things being the second phase, and where prediction or proactive smart homes is the final stage. And this is yet to come once users are more open to this concept.
Moving on to the conclusion, the report examines the rapid revolution of smart home technology, focusing on three main approaches: the mobile-based, device-based, and AI-driven proactive systems. It highlights the pros and cons of popular systems like the Apple HomeKit and the Amazon Alexa, the connectivity options like the Bluetooth, Wi-Fi, Zigbee, and the Meta emerging as a promising unified platform despite security issues. The report also explores the interactive features like the voice and gesture control, noting their potential and limitations. For instance, the voice control can suffer from the accuracy issues, while the gesture control may require the wearable sensors for better results. Proactive smart home approach is emphasized for its role in energy conservation, although it arises security and privacy concerns due to always-on sensors. In summary, the smart home systems offer innovative solutions, but face challenges in integration, privacy, and security. About the future direction. In the future, the smart home systems are expected to become more advanced and focus on the user experience by integrating multiple technologies. These include the gesture-based interactions, augmented and mixed reality displays, and artificial intelligence proactive system management. According to research, current AI functionalities in smart homes mainly involve the voice and image recognition. However, the future developments are likely to include activity recognition and predictive data analytics. The mixed reality technology, already proven to offer detailed user interfaces and comfort wearability, will find broader acceptance in various industries, including the smart homes. This will allow for more interactive and ongoing assistance in the task completion. For example, the platforms like the Apple Vision Pro could extend the smart home operating environment beyond just the mobile phones. The artificial intelligence will also play a crucial role in understanding the user behavior within the smart homes. The sophisticated learning algorithm will adapt to changing users' needs and conditions, such as the seasonal variation. This adaptability will be particularly useful in energy management, where the AI can predict the optimal times for deploying the clean energy. In summary, the future of smart home systems lies in the seamless integration of device-based controls, multi-sensory interactions, advanced AI functionalities. This will lead to a more comprehensive home automation system that enhances comfort, increases energy efficiency, and reduces costs.